if we want to find the equation of the tangent line at x equals 2 to some function, all we have to do is find both a point and a slope. Right? Point should be easy enough. That should just be f of 2 or 2 comma f of 2, which is what? 2 comma
-1.
All right, arithmetic, good. And then our slope should just come from f prime of x is 2x minus 3. So f prime of 2 ought to be
1.
And we end up with y minus -1 equals our slope 1 times x minus 2. Easy enough? Do we need to look at the Desmos graph of that, or no? We good? All right, we're good. Cool. Let's find the equation of the tangent line at x equals 3 of this function. What do we need to do? We need to find f of 3, right? What's f of 3? The natural log of
95.
95. Yeah. And we need to find f prime of 3. So f prime of x is what? 1 over 3x cubed plus 5x minus 1 times the derivative of 3x cubed plus 5x minus 1, which ought to be what? 9x squared plus 5. And if we evaluate that at 3, what do we get? Ought to be 86 over 95. You guys agree with that? Or no? Does that look good or no? Did I do my arithmetic right?
All good.
All right, let's graph this one. That'll be fun. What was our original function? Natural log of 3x cubed. What was it? Plus 5x minus 1 plus 1 minus 1, right? That didn't work out. There we go. There we go. Look at that nice little tangent line there at 3 comma natural log of 95. Okay. And we'll note something to note here is that when the function is concave up, tangent line is, or sorry, concave down, tangent line is always above it, right? And so if we used a tangent line to approximate the value of the function on a concave down function, that tangent line approximation will always be greater than the actual value. If the function was concave up, it'd be the opposite, less than. Good or no? Cool. We'll go with that. It's good. All right. So here we now have a parametric. So we'll slow down here a little bit and take this one a little more slowly. We want to find the equation of all tangent lines to this parametric at the point 0, 4. And we're going to say that t is between -infinity and infinity. Okay. So we got all real numbers t here. So for this parametric, let's graph it first. How about that? Let's start with the graph just to get an idea of what this looks like. So we had what, t to the 5th, I think. All right, t to the 5th minus 4t cubed, and then what was the y coordinate?
T squared.
Just t squared?
Yes.
All right. And since we can't do negative infinity to infinity, we'll just put in a couple of big numbers here. It looks like between negative 100 and 100, it's going to hit that 0.04 twice, right? And so this is the difference, the first difference that we might see when we're talking about tangent lines when we start dealing with parametric and polar functions, is that these equations might cross through the same point more than once, giving us multiple different tangent lines at the same point. So we have to make sure that we account for that. Okay, so note that there are two different places, or two different t values that give us the 0.04. Everybody see that? Hopefully. So first off, what do we need to do? We need to figure out the derivative, right? Because the derivative will tell us the slope of the tangent line. So what is dy dx here for this parametric? How do we do that? This will be a good review for your quiz tomorrow. Derivative of parametric is just dy dt, which is
2t.
2t over dx dt, which is 5t to the 4th minus 12t squared. Good or no?
Good.
Good-ish. We'll divide a t out of all of it because we can, just to make some arithmetic later easier. 2 over 5t cubed minus 12t. Everyone all right with that? Okay. So now the question is, how do we figure out the actual equation of the tangent line? We know the slopes are 2 over 5t cubed minus 12t, and we know the point is 0, 4, but I need to figure out what? I need to figure out the t value to plug into this derivative to get the right slope, don't I? So how do we figure out the correct t value?
Maybe find which t values give you the values of the point.
Give you the values of the point, is that what you said?
Yeah.
Yeah, so we know that x needs to equal 0, right? So if x is 0, we know that t to the 5th minus 4t cubed needs to equal 0. And what can we do with that? We can factor out a t, not a t squared, a t cubed, giving us t squared minus 4. And when does this happen? This happens at t equals 0 and at t equals positive or negative 2. So it looks like we have 3 different t values that give us an x value of 0. Everybody agree with that? Hopefully so. What about when y is equal to 4? That would just be when t is positive or negative 2. So what we have to do, once we've solved both of these, we have to only look for the overlap, because not only do I need x to be 0, right, which comes from all 3 of these values, but I also need y to be 4, which only comes from these 2. So I need the ones that overlap. So at t equals positive or negative 2 are both of those points true, or both of those values, 0 and 4, true for x and y. This one we'll ignore because it's not included over here with the y values. Everybody good with that?
Yes.
All right. So dy dx evaluated at t equals 2, and dy dx evaluated at t equals negative 2. What do we get for each of those? Two cubed is 8, times 5 is 40, minus 24 is 16. And here, negative 2 cubed is negative 8. Negative 40 plus 24 is negative 16. So we got negative 1/8. And these are y-intercepts of 4, right? So these ought to be y equals 1/8 x plus 4, and y equals negative 1/8 x plus 4. Everybody good with those two equations? There's x over 8 plus 4, definitely tangent at 0, 4. And then negative x over 8 plus 4, also tangent at 0, 4, just going the other direction. Good or no?
Awesome.
Yeah, kind of looks like a radish. Sort of an extended out radish, doesn't it, Gina? No response. Any questions on that? All right. Let's find the equations of all the tangent lines to sine t, 3 cosine t at the point root 2 over 2, 3 root 2 over 2. So let's try and do this without graphing first, and we'll graph it to check our work. So first off, when does, and we'll just, since we're doing trig functions, we'll just say t is on the interval 0 to 2 pi. Because otherwise it's just going to repeat after that, right? It looks exactly the same. So when does sine of t equal root 2 over 2? When t is
Pi fourths and 3 pi fourths.
pi over 4 and 3 pi over 4. Okay. And what about this one? When does 3 root 2 over 2 equal 3 cosine t? Well, we can divide by the 3's, right? And that just gives us cosine of t is root 2 over 2. So that'd be at t equals pi over 4. And when's the other place where cosine is equal to root 2 over 2?
7 pi over 4.
7 pi over 4. And so this time we'll see that there's only actually one value where these overlap, is at t equals pi over 4. So we'll ignore these because they don't occur on both sides. Good? All right. Now we need to find our derivative. So what's dy dx? It ought to be derivative of 3 cosine t is negative 3 sine t. And our derivative of sine t is cosine t. So this gives us what? Negative 3 tangent t if we simplify it down. And if we evaluate that at pi over 4, what do we get? Should just get negative 3. And our equation ought to be y minus 3 root 2 over 2 equals negative 3 times x minus root 2 over 2. Any questions on that? Everybody good with that? All right, let's take a look at it on Desmos. So what do we have? We had sine t, comma, what was it, 3 cosine t? We got this nice ellipse here. And we had y minus 3 root 2 over 2 and negative 3 times x minus root 2 over 2. And there it is, tangent to our ellipse at that point. Looks pretty good there, doesn't it? Everybody good with that or no?
Good.
Cool.
Any questions or issues so far?
So the number of tangent lines you're gonna have to find are gonna be
is going to be equal to the number of t values that satisfy that coordinate?
That, yes, that satisfy both of those x and y values, correct.
Okay.
So, I mean, you could have up to, you know, an infinite number of them. I mean, obviously we won't do that, but like you could theoretically. You might have 0, you might have 2, you might have 1, you might have 7, who knows. All right, you guys want to give this one a try on your own real quick? Cool, no response. All right, give this one a try on your own. What?
Yes, I would like to.
Yes, all right, great. I'll give you guys 2 or 3 minutes here to work through this one. This one's a little bit different. I gave you the appropriate t value, right? So I just want to know t equals pi/2, so you don't have to do that second, more annoying part. Ready, go. So first off, what's our dy dx value? Ought to be 18 secant squared 6t over what? Negative 6 sine 3t minus 12 cosine 3t. Everybody agree with that?
I agree.
All right, great. And we could simplify that all out with the 18, the 6, and the 12 if we wanted. 3 secant squared 6t over negative sine 3t minus 2 cosine 3t. And what do we end up with if we evaluate that at t equals pi/2? This becomes the secant of 3 pi. What's the secant of 3 pi? Secant of 3 pi ought to be -1, and if we square that, ought to give us 1. So that gives us a 3 in the numerator. And what's the sine of 3 pi/2?
-1.
-1. Put the negative in front of it, gives us +1, and then cosine of 3 pi/2 ought to be
0.
0. So we just end up with a slope of 3. And then what else did you have to do with this one? Since I gave you the t value rather than the point to evaluate it at, we just needed to figure out what point this hits. So x equals 2 cosine of 3 pi/2 minus 4 sine of 3 pi/2. What's the cosine of 3 pi/2? Should be
0.
still 0. And our sine of 3 pi/2 is -1, so we end up with 0 plus 4. So we have an x value of 4. And what's our y value? 3 tangent of 3 pi. And what's the tangent of 3 pi? 0. So y minus 0, right, equals 3 times x minus 4. Everybody good with that or no?
Yeah.
Should we take a look on Desmos at it or no?
Why not?
All right, so we got 2 cosine 3t, right? What was it? Minus what? Minus 4 sine 3t. And what was the other one? It was
3, 10, 6.
3 tan 60. And we'll go from 0 to 2 pi, we got something that looks a little bit like this. And our equation that we got was y equals what, 3x minus 12, I think, if you just distribute that out. So if we go in at 4, 0 and look, it's definitely tangent here at 4, 0, right? Our linear piece is staying to the right of our curved tangent piece. Everybody good with that or no? Any issues? Yeah, you're all good? Okay. Cool. So have you guys do one more of these. So I'll give you about 3 or 4 minutes to work through this one. Should be enough. It looks bad, but the derivative and the values when you plug them in don't turn out to be so terrible. So should be pretty easy. Ready to go. So we'll do the easy parts here while we're letting people finish up if they're not quite done. To figure out when x is equal to -3, all we need to do is set that equal to -3, right? Which ought to give us t squared minus 2t minus 8 equals 0, or t minus 4 times t plus 2. So I got two values, t equals 4 and t equals -2. Everybody good with that?
Yes.
All right. And then on the other side, if we set that equal to 7, we can cancel out the 7s. And if we factor out the t times the t minus 4 squared, we end up with t minus 4 minus 3t. All of those equal 0. So we end up with t equals 0, t equals 4. And then this one becomes -2t minus 4 equals 0, or t equals -2. So it looks like we have an overlap of two different values. T equals 4 and t equals -2. Everybody agree with that? Yeah,
Yes.
no, maybe, yeah. All right, cool. So then we need to find our derivative. So finding our derivative is going to be a little bit of a pain, but not too terrible, hopefully. So how do we find our derivative? dy dt over dx dt, right? So our denominator is just going to be what? 2t minus 2. And in the numerator, the 7 will go away, right? And we got t times t minus 4 cubed. That's product rule, right? So that'll be t times 3 times t minus 4 squared plus t minus 4 cubed. And then our minus 3t squared times the t minus 4 squared, that'd be minus 3t squared times 2 times t minus 4 plus -6t times t minus 4 squared. Is that what you guys got for your derivative?
Yeah.
Okay. And you may have simplified it down some. I'm not going to bother. First off, if I need to figure out at t equals 4 what that comes out to be, so we'll say dy dx at t equals 4, what's that going to be? Well, all of these have a t minus 4 in them, so that's just a bunch of zeros. Everybody agree with that? Hopefully.
Yeah.
And what did you guys get when you plugged in -2? not going to go through all the arithmetic on that if I don't have to. So what'd you guys get?
I got -96, but does someone have something different?
Anybody agree with that? Disagree with that?
Negative
Nobody else.
24.
What?
maybe. I got something else. But
Yeah, I
you
got
had-
-24 too.
-24. I guess maybe we should go through and do that arithmetic. All right, so if t is -2, I have to go back and forth here a bit. So that's -6 times -6 squared. So -6 times 36 ought to be what? -216.
Wait, can I start back to your derivative really quickly? Shouldn't it be like a negative, like so -6t times t minus 4 squared?
I do have a -6t there.
Oh no, because like when you do the product rule for 3t squared times t minus 4 squared, it's a positive, and then you have to distribute the minus sign, right? Or unless you're including it there.
Yeah, I just included the negative as like -3t squared times t minus 4 squared. So I have -3t squared here times 2 times t minus 4, and then
Okay,
plus.
never mind. Sorry then.
Yeah.
Okay.
All right, so okay, we got -6 times 36, right? Which is -216, and then we got another -6 cubed, so that's -216 minus 216. And then we got minus, this one comes out to be what? That's 4, that's -12, that's 24. What's 24 times 6? 144, right? So this is a plus 144 in the end there. Everybody agree with that? Maybe. And then this becomes 36 times -6, which is a -216, times a -2, so that becomes plus 432. Did I do
Wait.
that all correctly or not?
It is 24. I forgot a negative sign in there.
Well, then that means divided by, I gotta do the division, right? Divided by, what is that, -6? Yeah. So that ends up giving us -24. Is that what you guys were saying, -24?
Yep.
Cool. All right. So -24, and we know the point is -3, 7. One of them has a slope of 0, so that'll just be y equals 7. And the other one has that slope of -24, so that'll be y minus 7 equals -24 times x plus 3. And I think this will be a good one for us to take a look at in Desmos, just to make sure we didn't screw anything up. So our original function was what? T squared minus 2t, what was it, minus 11 or plus 11?
-11.
Minus 11. And then our other one ought to be
T times the quantity of t minus 4 cubed
t minus 4 to the third.
minus 3t squared times t minus 4 squared. Plus
And then
7.
plus 7. Right? Cool. So if we zoom it out, it looks like this. Can't really see all of it unless I zoom it out pretty far. Yeah. but we will note that there are two places where it does equal -3.7 right here. One of those does look like it ought to be just this horizontal line right there, touching the top of that thing that sort of looks parabolic. And then what was our other one? Y minus 7 equals -24 times x plus 3. And if I zoom in on that at -3.7, we're not going to really be able to see the difference between them because it's so steep there. But if we zoom out enough, maybe we can see that it's coming in here and being tangent there. And still, if you look way down here, you can see the green is just a little bit still to the left of the black on that. So there are two different tangent lines there. Good or no? Wasn't that fun? Any questions on that? Got the idea of it? Pretty straightforward, just not the greatest arithmetic always. All right, let's do one here with a polar function. We'll do a few more with polar next time. Get at least one or two in here today. We're not going to get through it all. So we want to find the equation of the tangent line when theta is pi/6 for r equals 2 sine 3 theta. What does r equals 2 sine 3 theta look like? Should they remember that? It's only been a couple weeks since we talked about polar stuff and what the graphs look like. What kind of curve is r equals 2 sine 3 theta? All right, good. Thank you, Ryan. It's a rose curve with 3 petals. And r equals 2 sine 3 theta. There it is, right? The rose curve with 3 petals. We want the tangent line at theta equals pi/6. So let's see if we can figure out how to do that. First off, we need a derivative, right? We need a dy dx. How do we find dy dx? X ought to be r cosine theta, and y ought to be r sine theta. Yeah? So dy dx ought to be dy d theta, which will be 2 sine 3 theta cosine theta plus cosine theta, or sorry, sine theta times 6 cosine 3 theta. So 6 cosine 3 theta sine theta. Everybody good with dy d theta? And what about dx d theta? Should be 2 sine 3 theta times the derivative of cosine, so negative 2 sine 3 theta sine theta. And then plus the derivative of this, which is plus 6 cosine 3 theta times cosine theta. Everybody good with dy dx?
Yes.
All right. So dy dx at the value of theta equals pi/6 ought to give us, let's see, 2 times, what's the sine of 3 pi/6, or the sine of pi/2?
1.
1. What's the cosine of, oh, that should just be, oh yeah, it's just cosine theta, it just looks like a 3. What's the cosine of pi/6?
3/2.
Good. And then we got 6 times the cosine of 3 pi/6. What's the cosine of 3 pi/6, or cosine of pi/2?
0.
0. And then sine of pi/6 is a half, even though that doesn't really matter now because our cosine was 0. And then down here we got -2, and we got sine of 3 theta, so that's still 1. And then sine of pi/6 is a half. And then this whole second part here, because of the cosine of pi/2, ends up being 0. Everybody good there? So what does our slope end up being? Negative what? If you simplify that down.
Negative root 3 over 2.
This is negative root 3.
Oh, I missed the 2. My bad.
Yeah, those twos will cancel, and then those twos will cancel, right? So just negative root 3. And then we also need to figure out what is x and what is y at theta equals pi over 6. So x of pi over 6 is what? Should be 2 times our sine of 3 theta, which is again 1, and then times our cosine of theta, which is what? Root 3 over 2. So what is our x value? Just root 3. And y at pi over 6 at theta equals pi over 6 ought to be 2 times 1 times our sine of pi over 6, which is a half, or 1. So we got y minus 1 equals root 3 times x minus root 3 as our equation. Everybody good with that?
Isn't it negative root 3? Slope.
Oh yeah, sorry, negative root 3. Yeah, I had that up there. All right, y minus 1 equals negative root 3 times x minus root 3. And if we throw that in here, y minus 1 equals negative root 3 times x minus root 3. There it is. Tangent to our polar curve right there at whatever this point is. And yeah, clearly tangent to it. Yeah. Good or no?
Yes.
All right, we got the idea on the polar ones. Similar process for all the polar ones. We'll do some more. We'll do a couple more, maybe one more today, and then another one or two tomorrow. So last one for the day right here. You guys want to do this one on your own?
Yes,
Sure.
please.
All right, cool. I'll give you about 4 to 5 minutes and then we'll go through it. Ready, go. Our x value ought to be 2 plus 2 cosine theta times cosine theta. And our y ought to be 2 plus 2 cosine theta times sine theta. And at x equal, or at theta equals pi over 4, we got to end up with x equals 2 plus 2 root 2 over 2 times root 2 over 2. And y ought to equal 2 plus 2 root 2 over 2 times root 2 over 2. And those should simplify out to be, what do those simplify to? Let's see. 2 plus root 2 times root 2 over 2 ought to be root, what does that come out to be? Root 2 plus 2? No, root 2 plus 1. Everybody agree that those both equal 1 plus root 2?
Yes.
All right, cool. And so then our derivative, dy dx, ought to be, and we can use the product rule here. So 2 plus 2 cosine times negative sine plus cosine times negative 2 sine over 2 plus 2 cosine times cosine plus sine times negative 2 sine. And if we want to, just throw those in and evaluate it, but I think it's a little easier if we simplify this down. So negative 2 sine theta minus 2 sine theta cosine theta minus another 2 sine theta cosine theta. Over 2 cosine theta plus 2 cosine squared theta minus 2 sine squared theta. And we can simplify that down to negative 2 sine theta minus 2 sine 2 theta. Each of those is a sine 2 theta over 2 cosine theta plus 2 cosine 2 theta. Everybody good with that? All right, pi over 4, that becomes negative 2 root 2 over 2, or negative root 2. And then the sine of pi over 2 is 1, so negative root 2 over 2 minus 2 over, and then 2 cosine theta is just root 2, and cosine of pi over 2 is 0, so we have negative root 2 minus 2 over root 2, which if we want to simplify is negative 1 and then a minus root 2. That's our slope. And so what should our equation of our line be? Y minus 1 plus root 2 equals negative 1 minus root 2 times x minus 1 plus root 2. Is that what you guys got?
Can you go back to the derivative, like the previous page?
Yeah.
It looks like it's like dx d theta over dy d theta.
No, did I flip them and do them the wrong way?
Yeah, I
Yeah,
think so.
because it should
Because
be
I got
2
the exact
plus.
same derivatives.
Oh,
flipped.
I did, didn't I? Oh, geez. All right. Nobody could have told me that earlier. Man. So we got 1 over that. Is that what you guys got?
Yes.
All right. Dang. Wish somebody mentioned that earlier. Oh, well. Thank you. Yeah, I don't know. I just looked at that first one and did it. Oops. Flip all those. And if we try to graph this, we got r equals 2 plus 2 cosine theta. And we had y minus 1 plus root 2 equals, all right, now I don't know what I had though. 1 over negative 1 minus root 2, right? Times x minus 1 plus root 2. There we go. Looks good, huh? Tangent line to our cardioid right there at that point. At pi over 4, right? Good or no?
For this problem, can we just put the like have the multiply the cosine theta into the x first, then multiply the sine theta into the y to begin with? Is that
Just right here, say 2 cosine theta plus 2 cosine squared.
yeah?
Yeah, that's fine. Sure.
Okay.
You can do that with any of them.
That's what I did, and I got the same answer.
Yeah, it'll come out the same. You might have slightly looking different value here because I simplified mine a little strangely since I had accidentally done the reciprocal of it first. But all right, that's it.